Welcome back to Digital Dimension. It's great to have you here again. I want to apologize for not uploading a video last week. I was sick and couldn't get one out. Thank you so much for your patience and for coming back. Let me give you a quick introduction to today's subject. Imagine standing at a crossroad where each path leads to a different adventure based on the weather. Just like in real life, our programs often face decisions. Today, we're diving deep into how Python uses if, else, and Elif statements to navigate these decision points. Welcome to the art of making choices in programming. Before we dive into today's lesson, let's quickly recap what we covered last time. We began by discussing the importance of comments in Python, which allow you to add helpful notes in your code without affecting its execution. Comments are great for making your code more understandable to others and to your future self. Then, we explored the foundational concept of variables, which are containers for storing data that can be used and manipulated throughout your program. One powerful feature of variables is that they can be reassigned, meaning you can change the value stored in a variable at any time. We also delved into various data types that these variables can hold. Strings are used for text, allowing us to store words and sentences. Integers are used for whole numbers like 10 or -5, while floats handle decimal numbers, allowing for more precision, such as 3.14 or 0.001. Finally, we talked about booleans, which are used for conditions and can only have two values, true or false. Additionally, we discussed proper variable naming conventions, emphasizing the importance of using descriptive and meaningful names to make your code clear and easy to read. These basics are essential as they form the building blocks for everything we'll do in Python. Did you have any questions or doubts about what we covered? Please leave a comment and we'll do our best to help you out. With those fundamentals in place, let's now explore how we can make decisions in our code using conditional statements. Let's start by understanding if statements. At its core, the if statement is Python's way of asking, is this condition true? If yes, then do something. It's designed to be as intuitive as possible, almost like speaking English. Think about how often you say things like, if it's sunny today, I'll go to the beach. Or, if this pizzeria isn't too expensive, we'll eat there. Maybe even, if I play till 6 a.m., I'll be really sleepy tomorrow. Who's guilty of this last one? Hands up. These thoughts present us with options. If what we imagine happens, we take one path. If it doesn't, we take another. Let's focus on the sunny day example. If it's actually sunny outside, then our thought, or in programming terms our condition, is true. If it's not sunny, then the condition is false. Depending on this boolean value, remember booleans, we decide whether to go to the beach or not. An if statement is like a question that leads to an action. Let's start with a simple code example. Checking if a number is positive. First, we set number equal 1. Then we write if number bigger than 0, we print positive. Here we can see the syntax, the specific way to write an if statement. We start with if, followed by the condition we're considering, in this case whether a number is positive, and we translate this into something the computer can understand. A positive number is 1 greater than 0. We could use any condition here like is sunny equal true or name equal Peter. Have you noticed the use of two equal signs here? In Python, when we're comparing values, we use two equals to check for equality. This tells Python that we're asking if the values are the same. In contrast, a single equal sign is used for assigning a value to a variable. It's important to remember this distinction. Double equal compares, while one equal assigns. After specifying the condition, we add a colon to indicate that what follows depends on the condition being true. Then, we indent the next line where we write print. Indentation is crucial in Python. It tells the interpreter that the indented code belongs to the preceding if statement. This structure is vital for ensuring that your code executes correctly. Now, what happens if the condition is not true? That's where the else statement comes into play, which we'll explore shortly. For now, try running this code and see what happens. Then change a number variable to a negative number and observe the result. Also, try removing the indentation before print and see what happens when you press run. This is just the beginning. Depending on conditions like user input, time of day, or even game scores, if statements can guide our programs down many different paths. Now, like we referenced before, what if our condition isn't met? Let's revisit the sunny day example. What if the day isn't sunny at all? Or what if the number isn't positive? This is where the else statement comes in. The else statement provides an alternative path when our if condition is not true. Think of it as a fork in the road. Let's apply this to our positive number example. The else statement comes after the if statement block. A block of code is a group of statements that are executed together. In this case, we're dealing with an if statement, so all the code under it that's indented belongs to that block. The else statement should be written at the same indentation level as the if statement. Think of your code as a series of steps in a staircase. The if statement is like one step, and any code that follows it is a smaller step directly connected to it, slightly elevated, creating a clear progression. The else statement, however, should start at the same height as the if step, meaning it aligns horizontally with it rather than being elevated or lowered. This way, both if and else are on the same level, maintaining a clear and organized structure. If an else is at the same level as an if, Python understands they belong together. This is crucial because if the levels are off, the code won't run correctly. See what I did there? I used an if and an else statement while speaking. They're really common. Back to the code. To make our else statement work, we simply write else : It's that straightforward. Python automatically knows to run the code in the else block if the if condition isn't true. This simplicity is powerful, but it can also be a bit risky if you need more precise control over your conditions. If the if statement isn't true, the else block will execute, which might not always be what you want. Let's finish our example. We indent the code related to the else block and will write print number is negative. If the number isn't positive, it must be negative. But what if there's more than just two outcomes? This is where Elif, short for else if, comes in. Elif provides additional paths, each with its own condition. It's like combining an if and an else statement. In our number example, a number can be positive, negative, or exactly zero. So let's add an Elif statement. Elif must come after if blocks and before else blocks. You can have as many Elif statements as you need, but for this example, we'll just use one. The syntax is similar to if. We just add two more letters. Let's write Elif number = 0. Notice the double equal sign in the colon. Then we indent the next line and write print number is 0. Now run the code and see what happens. Try changing the number to 0 and observe the output. Now that we've explored how if, else, and elif guide our decisions in code, let's introduce a new tool, the input function. Just like print, which we use to display information, input is built into Python and is used to gather information from the user. While print pushes data out to the user, input pulls data in, allowing for more interactive programs. Let's see this in action with our number example. Instead of hard coding a number, we can ask the user to provide one. We'll write number = int input enter a number. The text inside the parentheses of input is a prompt that tells the user what to type. This prompt is displayed on the screen, guiding the user to enter the right information. Do you remember from the last video when we talked about being careful with data types? Here's an example of why that's important. The input function always returns a string, even if the user types in a number. By wrapping input with int, we're converting that string into an integer, which we can then use in our comparison. Now press run and see what happens. You can type your number and observe how the if statement gives you a print statement depending on your choice. This concept of built-in tools like print and input is a great introduction to function. Pieces of code that perform specific tasks. We'll dive deeper into functions later, but for now, let's see how we can use input to make our examples more dynamic. Let's put theory into practice by building a small program together. Our goal is to recommend activities based on the weather. We'll start by asking the user for the weather using input. For simplicity, we'll ask whether it's sunny, raining, or snowing. Using the if, else, and elif statements we've discussed, we'll suggest an activity based on the user input. Here's how we can do it. First, we'll capture the user input with the line weather = input. What's the weather like today? Sunny? Raining? Snowing? Do you remember what goes in between the parentheses in input? It's the prompt that guides the user on what to type. Now, let's write our first condition together. Start by typing an if statement that checks if the weather is sunny. If it is, we'll print the message, "Great, let's go to the beach." Next, we'll add an Elif statement to check if the weather is raining. If it is, we'll print, "How about reading a book indoors?" Then, we'll add another Elif statement to check if the weather is snowing. If it is, we'll print, "Perfect weather to build a snowman." Finally, let's add a last else statement. This will catch any unexpected input. If the weather isn't sunny, raining or snowing, we'll print, "I'm not sure what to suggest for that weather." Now press run and see how your program responds based on the weather you entered. This simple program demonstrates how conditional logic can make your code interactive and responsive to the user input. Before we dive into common mistakes and tips, let's take a moment to discuss logical operators, which are powerful tools in Python for combining multiple conditions in a single statement. The three main logical operators you'll use are AND, OR, and NOT. Let's start by assigning some variables together. Type the following: is sunny equal true, is warm equal true, is weekend equal false, is holiday equal true, is raining equal false. Now that we have our variables, let's see how we can use logical operators. The AND operator allows you to check if multiple conditions are true at the same time. For example, type this: if is sunny and is warm. If both conditions are true, you could print a message like "great weather for the beach." Next, let's use the OR operator. Try writing if is weekend or is holiday. This condition will check if either is true, meaning you can decide to sleep in if it's either the weekend or a holiday. Lastly, the NOT operator. It inverts a condition. For example, write if not is raining. This checks if it's not raining, allowing you to print a message like "no rain, time to go outside." But what if you didn't want to use logical operators? If you could achieve the same result by nesting if statements. For example, instead of using if is sunny and is warm, you could write if is sunny, if is warm, print "great weather for the beach." This approach works, but it can make your code harder to read, especially if you have many conditions. Logical operators help you write more concise and readable code, but there are scenarios where nesting if statements might be more appropriate, like when you need to perform different actions based on each condition. For instance, if you want to first check if it's sunny and, if true, then check if it's warm to decide between two activities, nesting can be useful. If is sunny, if is warm, print "let's go to the beach," else print "how about a picnic?" Both methods are valid and can be used depending on your needs. Logical operators are excellent for simplifying your code, but nested if statements give you more granular control when needed. The key is to choose the approach that makes your code cleaner and easier to maintain. Now, let's rephrase what we've learned. Think of the AND operator like needing both a game and a controller to play. The OR operator is like deciding whether to play an action game or a sports game. Either one will work. Using logical operators efficiently can drastically reduce the amount of code you write, making your programs not only shorter but also easier to read and maintain. Don't forget, logical operators make your code more flexible and efficient, and they're essential for writing concise and powerful conditions. Even seasoned programmers can trip over common pitfalls when working with conditional statements. Let's highlight a few frequent mistakes and some tips. First, a common error is forgetting the colon at the end of an if, elif, or else statement. Without that colon, Python won't know where the condition ends and the block of code begins. Another frequent mistake is confusing assignment, 1 equal, with equality comparison, 2 equals. Remember, 1 equal is used to assign a value to a variable, while 2 checks if two values are equal. Mixing these up can lead to unexpected results in your code. When comparing Boolean values, you don't need to explicitly check if they are true. For example, instead of writing if is day equal true, you can simply write if is day. This makes your code cleaner and more readable. Finally, now that you know about logical operators, remember to use them wisely and avoid overly complex nested conditions. Often, breaking down complex logic into simpler statements can make your code more readable and easier to debug. Time for a quick quiz. Let's see how well you've grasped the concepts of if, else, elif, and logical operators. We'll present you with 3 scenarios, and your task is to choose the correct conditional statements. Ready? Let's go. Scenario 1. You want to check if it's both sunny and warm before deciding to go outside. Which of the following is correct? Think about the correct answer. You're deciding what to wear based on the weather. If it's raining, you need to bring an umbrella. If it's snowing, you need to wear a coat. If neither is true, you're good to go. Which statement correctly handles this? Take a moment to consider your answer. You want to sleep in only if it's the weekend or a holiday. Which conditional statement will you use? Pause and decide which option is correct. Choose the right answers and let's see how well you understand conditional statements. Share your answers in the comments below and let's discuss. This is a great way to test your knowledge and get feedback in real time. And just like that, we've explored the power of conditional statements in Python. We started by understanding the basics of if, else, and elif to make decisions in our code. We then introduced inputs to gather user data, learned about logical operators to combine conditions, and discussed common mistakes to avoid. Each of these tools unlocks new possibilities in your coding journey. Keep practicing, dive deeper into these concepts, and don't be afraid to experiment. As a next step, try creating a small program on your own. It could be anything from a simple game, like navigating a user through a story based on their inputs. This practice will solidify your understanding and boost your confidence as you move forward in your Python journey. If you found this video helpful, give it a thumbs up, subscribe for more Python adventures, and share your thoughts or questions in the comments below. Happy coding, and see you in the next dimension.